Okay, so let's get started. We're going to be taking a look at setting up and working with our gear cut feature based around a sequential transmission and a strain gauge that's going to be bonded to either the shift knob or the shift lever. This is going to be unique in the control strategy for the shift cut, so we want to make sure we're understanding all of this, and we're going to break it all down here in this training module. Now, the one thing that we want to note here is this is a basic look at the shift cut feature for a sequential and a strain gauge. We will have some more programming options that are more some advanced programming options we don't need to get into at the moment to get your vehicle up and running with the sequential and the strain gauge. So we're going to go through the essentials in this tutorial. The next tutorial we'll talk about, kind of continuing on from this tutorial, talking about setting up some of those advanced options and what they mean. So let's jump in here and take a look at getting started with our sequential control for our gear cut feature. So what we want to do here is go into our layout dropdown. We're going to move down here. We have two different layout pages for sequential shift up and sequential shift down. Now I've separated these pages so that we could access the tables as easy as possible. Let's go here to our sequential shift up and we'll jump in and start to talk in through our gear shift control strategy here and start to get this going and set up our strain gauge and making sure that this is all configured correctly. We'll see what tables we have available for programming and then talk about how the control strategy is going to work. And then I'll model it here on the engine simulator so you can see what this is going to look like. Okay, so the start shift mode, we're going to go from off and we're going to select in this tutorial gear lever force sequential. So this is telling the link that it's working with a sequential transmission, and we have a strain gauge that we're going to be feeding into the link that's going to translate a voltage to a shift force in units of newtons, and that's what we're going to use to signify up and down shift and when we want the shift cut to actually kick in. We do have other options with sequential transmission, such as our gear barrel position. I'm going to assume that your transmission does not have a gear barrel position sensor that we can bring into the link for shifting and for control. In a few tutorials from now, we'll be taking a look at the gear barrel position rather than using a strain gauge for a sequential. So this is going to be something we look at a little bit later. Also, digital paddle shift is another tutorial we're going to take a look at. That's where we start to automate the shifting process through paddles that we work with a pneumatic air shifter and into our control strategy. So that's probably the most complicated shift strategy we have with the link. We'll be looking at that in a few tutorials. Let's right now select our gear lever force sequential option and click OK. Now the next thing we have here is our end shift mode. We have time, digital input, gear barrel position. I'm going to assume again you don't have a gear barrel position. And when we're talking about doing a shift cut with a strain gauge, we're not going to be using a digital input option. We're going to be using time. The amount of time that elapses for the shift cut is what we specify here in these tables, and it will be very specific. So we're going to grab time as our option for this particular control strategy and click OK. The next few things, we take a look down some of our settings here. We have our cut mode. This is going to be specifying whether we want an ignition or a fuel cut for our gear cut strategy. Usually ignition cut is what we always select. Some engines are sensitive to ignition cut, so then you may want to consider selecting fuel cut. But ignition cut is much more effective at reducing the engine's torque output so that we can control getting the dogs to line up to each other and shifting in the upshift or downshift request. So typically ignition cut is what we choose. I'll be using ignition cut for this tutorial here, so click OK. Then we have our start shift validation time. Now, the way this is going to work, it's going to be taking a look at a shift force that's going to be coming from our strain gauge bonded to our shift knob or the shift lever. That's going to be sending a certain amount of voltage into the link, and we're going to translate that through a gradient here. We'll talk about this in just a minute. And then we specify a shift force that we have to exceed in order for a shift cut to happen. Once it receives an upshift or downshift force higher or lower than what we've specified here, then it looks at the start shift validation time. This is how much time it's going to wait before it moves into working with our dog unload and our shift cut, main shift cut strategy here. So it's kind of a debuffer. It's a period of time that it has to wait after receiving the signal. I would recommend to probably bump this up to something like 10 to 20 milliseconds if we're talking about a strain gauge sequential type of shift strategy here. All right, so the next thing we have here is our upshift TPS, APS low lockout, and then the TPS low lockout source. So because I'm drive-by-wire, I'm going to go here and choose APS, Accel Pedal Position. TPS is what you would typically choose if you're cable-driven throttle body, or you could work with this for drive-by-wire. This is going to be TPS, is tracking your actual throttle blade movement. Accel Pedal Position Sensor is better for drive-by-wire, so that's what I'm going to choose for my particular situation here. Now this low lockout is saying anything below 3% if we're requesting an upshift. This is for upshifts only. So anytime we're hitting the sequential gear lever to go into an upshift and we're going to be below 3% throttle, it's not going to apply the overrun upshift request or any of the main shift cut request. So it's going to ignore and essentially block out any of the shift strategy from happening. Now you're still able to mechanically get the gear change to happen, but it's going to say anything below this, it's not going to allow it to happen. It's not going to allow the control strategy to happen. I would probably recommend to set this to something low. I'll set it for right now in the demonstration to 0%. So anything more than 0%, it's going to allow some type of a correction to be applied when we're slightly on the throttle or we're at full throttle. The next thing we have here is our drive overrun TPS APS. This is going to be telling the link whether your engine's under power or you're in overrun decel conditions. If we scroll down here a little bit, we're going to notice that we have our driven upshift, and then we also have our overrun upshift. So the driven upshift tables, which in this particular page layout that we're looking at, are going to be the left tables right here. These are all related to our driven upshifts. We can see these tables here. They're all brought into our window right here for editing and viewing purposes. The overrun upshift we can find that's associated to these tables are found here on the right side of our screen. So we can access those portions for tables for programming over here. That is one thing I wanted to talk about here in the layout I've designated here. We have sequential shift up and sequential shift down. I've separated the upshift requests between driven and overrun, and I separated the downshift requests and downshift tables into the driven downshift and overrun downshift split over here. And that way we can keep track of things a little bit easier, because it's very easy to get confused as to which table is associated to which function. So for example here, if we're taking a look at our driven upshift, there's a dog unload duration here, but if we take a look at our driven downshift, there's also a dog unload duration. That can get confusing if you have a bunch of tables populated here. Link does not specify dog unload duration upshift or dog unload duration downshift, which is why I've split these into separate pages and kind of group things together here. So hopefully that makes sense. But more importantly, as we're on the topic of this right now, it's saying here 3% throttle and less, it's considering us to be in the overrun upshift table. So this is going to be used for the control strategy. 3% throttle and higher, it's going to be then assuming that the engine's under power, and it's going to use the main tables here, or the driven upshift. So the driven signifies we're under power. The overrun signifies that we're in lift throttle, not under power, and it controls things a little bit differently here in the strategy. So that hopefully makes sense. I'm going to base this drive overrun source again on Accel Pedal Position, because that's going to be what I'm working with here for my particular application. If you're a cable-driven throttle body, then select TPS. Let's click OK here. The RPM low lockout, this is saying it's blocking out any shift cut if we're anything below 1,000 RPM. Typically 1,000 to 2,000 RPM is what you're going to put here. I'll put 1,000 RPM here for the tutorial for demonstration purposes. There's a speed lockout. There's no reason we need a shift cut happening anything lower than 2 miles per hour. In fact, that probably raises up to something like 5 miles per hour. That way, when you're trying to make this work, you need to be moving a little bit for a gear cut to happen. 2 miles per hour is fine for right now. There's an end of gear lockout. This is very useful if you've set up your gear detection. So we can see right here, gear detection mode. If you set this up on RPM speed and you've defined your table here, set it under user define, and you've set up your table. We've talked about how to do this in previous tutorials. So you can go back in the training course to see how to set this all up. It's actually really easy.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.